Hello, this is continuation to the video number 1, cluster analysis. As we saw that k-means works very well on clustering, but it has some limitations, especially with the size of the cluster, that all of them should be equal. So we are looking at different techniques that might help us. One of the most popular also techniques, hierarchical clustering. What it does, it produces a set of clusters that they are organized with each other like hierarchy tree, and you can visualize it as a dendrogram, and based on how much you wanna go deeper in your clusters, either you start bottom up or you up down. For example, either you create a cluster first for each point in your data set. So we have 1, 2, 3, 4, 5, 6. So each one of them will be in one cluster. Then you join the one that they are similar to each other. For example, 1 and 3 will be in one cluster, 2 and 5 in the second cluster, and then you have a bigger cluster that has 2, 5 and 4. You can see it in hierarchy, and then if you have your cut in this area, you will have all this cluster that join from 1 to 4, and also including the 5. Now if you have the whole cluster, will be 6. Where if you are doing your hierarchy clustering up down, you start first with a whole data set, and then you start dividing. In this case we have the whole data set together, then you cut at this level, so you will have the 6 alone and all the rest in one cluster. If you cut on the second level, you will have the 6 alone, and then you will have the 2, 5, 4 in one cluster and 1 and 3 in other cluster. If you cut on this level, you will have the 2, 5 in one cluster, where the 1 and 3 are joined with the 4. And then if you cut on this level, you will go back to each point in one cluster. So those are the two different techniques in hierarchy clustering. It's what the strengths of hierarchy clustering, that you don't have to assume the number of clusters from the beginning, as we saw in k-means. K-means, always we needed to know the k, how much you want. 3 clusters, you want 6 clusters, you want 10 means, which means k equal to 10. So you have to decide in advance, whereas in hierarchy it's generated like automatically and by iterative, until you reach to a point that your clusters are good enough and you consider that the number that's been generated as a number of clusters will be considered. They can be also corresponded to a meaningful taxonomies. For example, in biology, the animals, the kingdom can be considered all those as example of hierarchy level. In the document, hierarchy is also very important, like nested topics. For example, sport, and as a sport you go into subtopics, which is maybe the basketball. You go in subtopic of basketball, maybe talking about the players, or another subtopic which is talking about the teams, etc. For example, here Yahoo directory. All of us, we know that when they started Yahoo directory, it was manually generated at the beginning, and they keep adding information. So how about doing this automatically, and instead of that, apply hierarchy clustering to the original web pages? So crawl all the web and do the clustering for documents similar to each other, and create the directory of Yahoo based on the similarity in those pages, and decide the label of each category or each cluster. Two main types of hierarchy clustering, and I described it previously, it's repeated here: agglomerative and division. So here the agglomerative, what you do, you start with a point as individual cluster, and then you keep merging. Whereas the division, you start with a whole points as one, and you start after that, splitting the clusters and the similarity between the points. Either you use cosine similarity, maybe any matrix you find it, or Euclidean distance between the points, and this is how you decide the split. Traditional hierarchy algorithm use similarity or distance metrics. Merge or split one cluster at a time. That's the basic concept. So here is the algorithm, and you have it also in your notes, and you can understand it very easy, a simple algorithm. It repeats, it merge to the closest and update the approximate matrix. So it's a really simple concept of hierarchy clustering. Many different metrics you can use to decide if two clusters are similar to each other, either and those are the distance. So either you use the minimum distance, so we find the minimum, where are those 2 points that they are the closest from the two clusters, and you say yes, those two clusters are similar to each other, or you decide the maximum. Pick the farthest point in one cluster and the farthest point from the other cluster, and you say, and you compare. For example, I have another cluster, let's say here, if this distance is smaller than the cluster here, that the distance is longer, then I will say those two clusters are more similar than the third one, so I joined or merged those two clusters. Group average, I will have to compute every combinations of points, the distance between them, and then have the average. Or the distance between the centroid. I will look at the centroid of each cluster. Let's say I have 10 clusters here. I'll compute the centroids between each cluster, and then I will decide which one is the closest, and I merge those two clusters. And of course, there are some different types of technique. For those points, so what kind of cluster I can first, the hierarchy clustering, using the minimum, found that those two are the closest, then found those two are the closest, then joined the third one, the fourth one, and the fifth one. And this is the technique that been used. So if I am using the minimum distance, let's say I have data looks like this at the beginning. Using the minimum, it can be split using the hierarchy with a minimum distance to two clusters, as you can see. What the strength of the minimum distance can handle non-elliptical shapes. So in this case, we solved the big problem that we had previously in k-means. For the comparison between those distances, all of them hierarchy, but the different distances, for example, how the procedure works, all of them first pick the first two classes, the second one in the word method pick this one, the other one also picked this one, and pick this one. Now you can see from the iteration a lot of similarity so far. Here the difference in the minimum, and continue, and you see the differences in computing the distance, either the minimum or the maximum, until we finish for the fifth set. So this is the differences we have one technique which is a hierarchy, but based on which distance you use, which matrix you use, you can generate different type of clustering. And as you can see, the cluster size is different, not like the k-means, not one size of cluster. So once a decision is made to combine two clusters, it cannot be undone. So here is the limitations of the hierarchy. Whereas in k-means, there is the iteration, it keep iterate, and it can be changed until find a better solution. Second one, no objective function is directly minimized. So another kind of optimization problem. Different schema have problem with one or more of the following. For example, very sensitive to noise and outlier, difficulty handling different sized cluster and convex shape, breaking large clusters. All those problems appear in hierarchy clustering. There is another new clustering algorithm, dbScan, is very popular for irregular shapes. So this is the original. It was able to find the noise and the core data automatically and distinguish between them. This is the original data, and automatically it found for us the clusters. It works very well. It's a new technique. It's time consuming to run it, that's all. So it is resistant to noise and can handle clusters of different shape and size. So the quality of a clustering is very hard to evaluate because we do not know the correct clusters. This is the most important the most evident and the most distinguished feature between clustering and classification. Classification, from the beginning we know how many classes we have, whereas in clusters we don't know how many, and we don't know how many will end up. We can control it at the beginning and keep trying to rerun our data until we found the best solution, but we don't know from the beginning how many clusters we have. Some methods are used to help us is user inspection. So we keep trying to find the centroid and spread the data and see how the clustering gonna work, or building a decision tree. For example, in text mining, as we know, it's very sparse data, very difficult to find topics related to each other and put them in one cluster, and it's really a hard problem, and we're gonna see it in our third video. I run it for you, so please try the dataset that is provided in this unit, just to see how many times you have to run the data until you get a good result. Now the question is how we can evaluate. Usually there are different types of evaluation, and really we noticed in classification we had some kind of recall, precision, accuracy, the support, we talked about those. In clustering there are different techniques to cluster, and mostly clusters are in the eye of the beholder. So you're the one who decide if the clusters are good enough or not. And there are different aspects of cluster validation. So we have to determine the clustering tendency of a set of data. So for instance, distinguishing whether non-random structure actually exists in the data. So this is a very difficult question. Or comparing the result and see which one is the best, and this is based on the validation that we're going to talk about. And evaluation, how well the results in the cluster analysis fit the data without reference to external information. Use only the data that in hand. And maybe comparing the result of two different sets of cluster analysis to determine which is the better. And that's another way. Could be maybe also determining the correct number of clusters, just to know how much clusters really is the real number, and the good number to have a pure cluster separated from each other with the right information. So it's mostly the 2 and 3 and 4 can be distinguished, and you want to evaluate the entire cluster or just individual clusters. So this is the question here, very important. Are you more concerned about to have each cluster has a very high purity, and the topics inside the cluster are very is so interrelated, or your concern is to have cluster that maybe the same topic is mentioned in different clusters, but however in each cluster only that specific topic is related. So based on what the assignment in hand, and based on your decision on deciding the number of clusters. The two evaluations that we use to decide our clusters, how good the clustering algorithm is, the entropy and the purity, which they both, if you sum them up, you should get 1. So the entropy is how much noise, how much errors you got, and you have the entropy. The first one is on the it is on the level of each cluster, so you count the entropy for each cluster. Then you have the entropy as a total. You sum up all the entropy for all the clusters in your data, in your clusters. So again, and that's why it's a negative, because it's an error, so the entropy can consider as an error. So for each cluster you see how much errors you have, then you sum up all those errors and you see how much error you have. The purity is just the opposite is a complement of the entropy, purity on the level of the each cluster, and then the purity as a total as a total number of document, for example here, over for each document over the all document multiplied by purity for each document, and the total getting for the whole document. And here you decide if the purity 90% for all the document that I clustered is good enough for me, that I would say these clusters are working fine with me. And watching the video 3, you have the application how Pluto can show you the results, and will be something similar to this one. For example, this data, small data, they run it on topics, documents topics, and it had 3 topics: science, sport, and politics. Maybe those data about documents, maybe in a blog, and some people talked about science, and people talked about sports, some people talked about politics. Then they took all those documents and they ran the clustering algorithms, and the clustering was able, just by the notion of the word mentioned inside the topic. We don't know, like the labels of those topics are taken off. We don't know those topics are related to what. Only we have the documents, only we have the word, the written comment maybe, and we run the clusters, and at the end we ended up with 3 clusters, each one of them, as you can see, not so pure. The first one mostly talking about science, but we have some errors. The second one is related mostly to sports, but see, this politics is very high, so that means this is not a very good clustering method that has been run on this data. The third one, we have also 210 is the highest, but 100, it's a problem here. So if you look at the entropy, how much error we have in for example here in this data set, the entropy is small, whereas here the purity is high. The second one is the purity is lower, as I said, because of problem of those 2 numbers. Here also the purity is as you can see also is not so high because of this number. In Pluto you will find a little bit different the measures. They sum up to 1. Here it doesn't, because they don't normalize the data here. In Pluto it will be easier for you. Just if you sum the purity and the entropy, you will find the result equal to 1. So go ahead and please install Pluto and download the data set of sports that's provided for you. Watch video number 3, how you can cluster data, and then you will have the last video just talking about how Pluto the input text and convert it to a matrix to be able to generate the clusters, because it's not very simple. Just you're not entering into the software a real world document, but you are converting the document into a matrices of 0 and 1, and then those information being converted into Pluto to be able to do the clustering and return back as text to be able to visualize it. I hope you got the notion of clustering so far with those 3 videos, and hopefully you will be ready for test number 3 that will contain part of this unit. Good luck, and please try to spend more time watching the videos and implementing, please. Pluto is very easy, easier than Weka. Just if you follow the directions, you will find it very easy, but also will take some time for you to find the best clustering for your data. Good luck.